Oh, hello guys, welcome to our 15th lecture. Today we are going to talk about linked list in Python. And linked list is covered in 165 at DVC. So let's get started. So today we mainly talk about what is a linked list and what are the components of a linked list. What are the tools to use or guys to modify a linked list, to construct a linked list, and how to use iteration, recursion to search, create, and modify a linked list. So how to insert a node and discuss the differences between a Python linked list, a Python list, and a Python linked list. So let's get started. So the first thing we are going to talk about is the structure of a linked list. So what is a linked list? Linked list is a list-like data structure. The list, in Python, in programming, is a bunch of data and uh, a bunch of data lie in a queue. So a linked list is a data structure in which each component is a node consisting of the data at the front, the data you want to store, or maybe we can call it a label. And at the back of the node is usually a pointer pointing to the next node of the list. So we have two examples of lists. And the first one, we call it singly linked list, which means that it's just a queue. It does not have something like circular. Um, no, we don't have a loop inside. But for the circular, we have a loop inside. So for a singly linked list, we have data at the front. We use this one. I've been used this pen for a long time. So we can call this label or data or link first. The first component of a link list. And the next one, we just store the pointer. The pointer is pointing to the next node. So the next node is also having the same structure of the first node. And for the tail part of the linked list, like the last node, um, we still have a pointer, but we're pointing that to now. Now means empty. Now means empty. So this is nothing there. It's basically so in my graph, I would say this is now nothing. And for circular linked list, at the tail part, um, the last uh, the last opponent of the node will be the pointer pointing to the head of this linked list. So this will never be now. This will not. This will never be pointing to a now. So this is single list and circular linked list. Yeah. So we will mainly talk about singly linked list. So a node of a linked list. If you use a magnifier to check uh, every node, you'll find this structure. The first one is the label, but we will call that link.first. And the last one we will call the link.rest. Like for this link at this part, at this node, the first component is the label or the data we are trying to store in this node. And the link.rest is a pointer pointing to the next node. So the rest part of the last node is a list of the list is called now. Now means empty. It's very similar to the C++ list. Like usually in a C++ list, say I have, oh, we call that array. Suppose I assign a variable to assign in array of 20. So for the very last element, it would be a now. If I remember it correctly, that would be the last element. You cannot store things at the very last part of the list, and this will space out for now, meaning empty. Is marking the end of the list. So also at this linked list part, it marks the end of the list because I'm not pointing something else after it beyond that. So okay. So this is the structure of a linked list. We call this linked empty. Yeah, link.empty. So I have three stuff. Link.first is the label of a node. A link.res is the pointer pointing to another node, like the following node. And link.empty is showing the end of the singular linked list, or showing this is now. Okay. So yeah. So let's talk about the definition. I'm borrowing the reference from CS101, and we can just check the three elements. This one is like, since we are using OOP to construct a linked list, to create a user-defined data type. So we have to know about, what is it out there inside of it, so we can know what kind of tools we can use. If I want to use this definition of this data type or definition of this link. So the first one, it is empty equals an empty tuple. So tuple, unlike list, tuple is the things that you cannot change inside. So yeah, so for empty, you cannot change that. And it is the class attribute of the linked list, which means that for this variable, uh, for all instances, if I use link.empty, this will only return a tuple, a tuple, and you can use that um, to analyze that if the link is an empty list, if a link is an empty linked list. Yeah. So for the next part, we have initial function. So the constructing function, we have self first res. Res is set to empty at default. So if you do not pass things inside, the rest will be empty. So it will be now. And the first will be the label you want to try to store, the data you try to store. Yeah. And for the rest part, because actually in Python, I don't think they have pointer things like a pointer. So I guess the rest part will be other linked lists. Yeah, other linked lists. Like suppose for this part, let's draw a graph. Suppose this is a knot, and the first will be this one, and the rest will be pointing to the rest of the links, right? So the rest part for here is referring to the rest of the linked list beyond this knot. Yeah. So this is the represent. Another thing is this is the representation and string. They override them. So try to make it readable. Yeah. So which we will not consider um, to try to know memorize. Yeah. But we have to know these three. Okay. So this is an example of a linked list. Um, yeah. Say this is a linked list starting from 1 to 4, and the very last part is 4. So when I make the first variable, so link is link 1, link 2, link 3, link 4. And you can observe it as this is the first part of the link, and the remaining are the rest. The remaining are the rest. They are pointing to the rest part of the list, like beyond that node. Okay. So for 4 here, because it's now, it does not pass into anything for the rest part. So it just pass in 4 for the very last node. So suppose I have a link like this, and the next part, we will be using link.first to see what link.first is. So link.first, it will be 1. So if you try to use a link at the very first thing, we would say, oh, link.first is this label. Yeah. And the next one, link.res. Link.res, like you also start from the beginning every time. You won't start unless you are trying to reinitialize your link. Otherwise, when you use the keyword link or something else for this variable, um, you will start from the beginning every time. Every time. So at the beginning, you try to know, oh, this is the first node, and first node, the rest part, the first node, and it will be this part. It's a pointer, but I will display, or I will return all this for the remaining part of the list. So let's see. Yeah, so the remaining part of the list, I have 1 and subtract 1, and I have all this left. So how about link.rest first? Again, I say start from the beginning because I didn't reinitialize the link. So start from beginning. And for the rest part first, the rest part of the first node will be this one, will be the remaining part of the link. So the remaining part of the link, this is remaining part link. The first one of the remaining part of the link list, it will be 2. So I will get 2. Yeah. And how about link.rest? Since we know that link.rest, like every time you use link.rest, it will be the remaining part of the list. Like you exclude the first node every time. If you have 2 rests, you exclude the first 2. If you have 3 rests, you exclude the first 3 nodes, etc., etc. Yeah. So how many every time you start from beginning if I didn't reinitialize? So link.rest will be the first node, and wait, link.rest link.rest will be everything excluding the first one. So we don't see this. And so this will be our new linked list that we try to analyze. So for the new linked list, meaning AKA the remaining part of the list. So we will try initialize again and link.rest, and because link.rest is the remaining, and the first, like the remaining of the remaining excluding the first one will be excluding 2. So we try and analyze it, and the rest part also excluding the third one. And for the rest part, I hit the last one. I hit the rest part, the last one. Since it's not pointing something, it's not pointing something, it's a now. It's a pointer pointing to now. So we will just return now, or else link.empty because we're using link.empty. So it will be returning link.empty. Yeah, maybe an empty tuple because we have seen the definition from the last slide, and it is an empty tuple. Okay, so this is how you first try to find the first one, and then the second one, the third one. You use the first one to find the label of one node. Use the rest part to find the remaining part of the list. Like I mean, excluding the first one. So excluding itself. So it's similar. It's very similar to ADT tree, but we don't have that much branches in linked list. It's only one branch. You can consider a linked list is a tree, but only one branch. Only one branch. For right now, yes. Yeah. For right now, yes. So you search in a linked list. How you search in a linked list? Like remember, like when we are using Python list, how we try to find something. Yeah, like how we try to find something. We use iteration or we use recursion. I guess we use iteration more often though. And this is the same in the linked list. But the thing is, I don't know about the position or the index, but that's fine. We can try analyze the first one of the node. And if you don't find the first one of the node, you don't find in the first node, you will jump into the second node. And if you still can't find that in the second node, you jump to the third node, etc. to the end of the node and showing, if the end of the node, the label is still not the one I want to find, I may return true, false, like depend on the situation. Let's say if you want to find something, and if you still can't find it in the last node, you return false, I guess. Yeah. So searching the linked list. The example of it is if the node number, like I given the linked list, if try to determine if in this linked list, do you have odd numbers in this list. If you have, you return true. Otherwise, like you travel through the linked list, you return false. So, okay. So I have a function here. Let's say I also have two examples. Say this is 2 and this is 4. So first one, second one. Yeah. So I will have objects and I pass in a link. The first link is to 4. And while link is in link.empty, like when I start search the first one. So every time you use the link.first, it will be usually the node of the label of the first node. So let's see, link.first, try to analyze if there's a node number and an odd number. Yeah, this is an like if this is an odd number, I return true. Remember when we use returning function, it will end the iteration. It will also end the function and return the value. So if that's true, you do not have to see all the remainings. But otherwise, you jump into the next one. Okay. So I guess we are familiar with this part. And how about this? Link is link.rest. What is that? Yeah, what is that? So it looks kind of weird, but it is reinitializing the linked list. So remember I just say if you use the keyword link or use the variable, it will usually display the first node, usually first student, first node. So if you point to the rest, it will be the remaining part of the list. And so that means that you are actually jumping from the first to the second. And the linked list, the link will be reinitialized as the remaining part of the list. Like you exclude the first node, and you try to throw it into the while loop, try again to see. So yeah, suppose for here, I don't think 2 is an odd number, so I would jump into the remaining part of the list and try to see. Okay. So while link is not link.empty, I will try analyze it. And 4 is also even number. Oh, shoot. So I had to jump to the third one. So, but for this time, this will be link.empty. This will be now because there's nothing left there. We've reached the bottom. So but we will still reinitialize it. But the link here will be now or will be link.empty. So I will try going back to the while loop, but this time while loop does not accept you. Why? Because you've reached the end of the link. Otherwise, it will be an infinite loop. So you will exit the while loop. And this time, because you've reached the bottom of the list and you still haven't found an odd number, it will return false. So for the first one, it returns false. Yeah, so the things I'm trying to say is like from next slide is that if you want to travel through a linked list using iteration, I mean using a loop like while and for, I guess usually while. Yeah, you use while if you use while loop, um, if you use while loop, you have the condition saying that to check if you have reached the bottom of the linked list. If you haven't reached the bottom of the linked list and you're still searching, at this time you can still continue in the loop. If you've reached the end of the linked list, like say this is now and maybe 4, and this is now, and the now marks the end of the linked list. And this time you still try to reinitialize the remaining part into a link, and then you jump back to the while. This time while the condition of while is to check if you've reached the bottom, meaning that if your link is already link.empty. So for the last step, for the very bottom, you will stop the loop and then return something else. Yeah. So the key point is this. Key point is the while loop will check if your link is empty link, link.empty. If it is link.empty, if it is now, which means you've reached the bottom, we've reached the end, which means I have to end this while loop. So this is iteration in linked list. Okay. So to use iteration, the base case is usually when processment of the link comes to an end. Yeah. If you comes to an end, you have to stop the while loop. So process the link by looking into the rest of the list, meaning that you jump from the first to second, you jump from the second to third, you jump from the third to fifth, etc. Okay, so okay, the third thing we have to modify a linked list. Yeah, because last part we're using iteration for searching, and this part we're using modify. We try to modify. This time we will use recursion and add a new node at the front. Um, Set the rest of the new node pointing to the previous list. Okay, so the first one is suppose I have a list like 2, 3, 4, and I want to append one. Suppose I have a link 1, 2, 3, 4, and I want to append. I want to add 5 at the front, at the head. So the 5 will be a new head. Yeah. So at this time, what we're trying to do. So suppose I have this link, and then the first one is like I want to construct a new node, saying, okay, the new link I construct node, I construct a node called link 5. At this time, 5 is 5 at the first part, and the remaining part will be null because I didn't pass something into it. And the next step, we want to reinitialize. So this will be my new link, and the link.res, I want to set the pointer pointing to the link above. So I just say new link.res is assigned to the link. Yeah, assigns link to new link.res. And you have another solution, which is new link is link 5 link. So link here is like when you create using OOP, this is the name of the OOP. Yeah, you have to think about all the capital link and the small link. The lowercase link is the variable. Like we try to create in to become a linked list. So link 5 link, and for this link is the rest part. So which means that I create a 5, and then I want to make 1, 2, and 3, or going to be the end of the 5 node. So you just create it when you are trying to create. You just append those links when you are creating a new linked list. Yeah. So make fun. Trying to append that at the back. Trying to append it. So you look through the link and then append the node at the back. Yeah, this one I use recursion. I guess this iteration is also fine. I guess, yeah, but yeah. But using recursion is the things that you are actually, I guess you're actually creating a new linked list, but that's fine. Yeah. Define append link number. And like this is the base case. If link is link.empty, so you construct a new linked list, construct a new node, and you say, oh, this is the last one. So I don't have something passed into the rest part. So it's just link and then 5. Yeah. Uh, otherwise, you still construct. Yeah, you still construct, and you construct. Okay, for suppose I have the one here, like we haven't reached the end of the linked list. So this will be a recursion. You have to believe that this part, meaning append link.res and then number. Oh, yeah. So link.res, append link.res, and then number. And you have to assume that using recursive leap of faith, you have to assume that it will return the linked list of 3, 2, 3, 4, 5. Like you have to assume that it returns the correct result. And for you, the things to do is to create a linked list using the the label of this one and the remaining part. And you believe that the remaining part is correct. So you just append this one, you append the label and the remaining part. Yeah, this will return a new linked list, but it's at the back. For you is to combine it from the front. Yeah, so this is adding a new node at the back. So how about delete? So suppose I've created 1, 2, 3, 4, 5 using the methods ahead of this slide. So the core thing is to skip the targeted node before or when hitting them. So I'm a bit complex here. Yeah, I'm a bit complex here for this function, but we can try looking at it. So like because for the first for here, the 3 is still inside this linked list. But for the next slide, when I try to delete this node 3, so it will be moving out of the linked list, and then you set the pointer. You set the pointer pointing straight to 4, pointing straight to 4. So I have very I have a very tricky one here, but I guess I will have another one better. So you see. So the first step is if link is link.empty. So suppose this is an empty link. You just return link.empty. And then the next part is if the link is only having one node and it is the number, and this is the number we're trying to looking for. So you still return link.empty. And otherwise, if you encounter this label saying that, oh, the first the label of the first node is the number we are trying to look for. So you you call this function again. You're trying to assume that this will return the correct result of all the stuff removed at the back. Yeah, because we are trying to proceed from left to right. You have to assume that everything at the right is already modified well. So, but you will set the pointer jumping to the next one, And I will say if link.res is link.empty, it shows that, oh, I have reached the end of the node. So I can construct the new linked list node again by like construct the 5 again by placing the label at the new linked list node. Yeah, and else if suppose I'm in the middle, suppose I'm at 2, and I find that the 3 is the one I want to delete, which means in the next node. So I will stop at 2 and then setting my pointer pointing to 4, like aka link.res.res. Yeah, link.res is 3 and link.res.res is 4. So I will skip the not 3. I will skip not 3. And otherwise I would just normally jump into the next node, Yeah. So I think this is a tricky one. It's a tricky one, but I guess I should have a better solution for this. I'm just saying, if you want to delete a node, you just skip the targeted one, when or before hitting them. Yeah, by setting the pointer, by setting the pointer, before that to the node after the deleted node, or if it's the first one, you just try to remove that at the front. Yeah. So okay, so next one, about inserting the linked list. This one is simple though. Inserting linked list is you suppose I want to insert after 2. So when I insert after 2, I have to set the pointer from pointing to 3 becomes pointing to 5. So it'd be 3, it'd be 2, and then pointing to 5. And at the same time, meanwhile, the new node, the pointer of the new node will be pointing to the remaining part of the linked list. And other parts of the linked list is just as normal. So suppose I have linked lists insert. So link dot first. Suppose link dot first is the member that after this member I want to insert here. So I return link dot first. Like still suppose I'm proceeding at 2, not 2. Suppose link dot first and this is 2 and link will be I will be constructing a new link. I will be constructing a new linked list by setting the label of the link will be the new stuff. And then for the rest part, I will still be the link.rest. Remember that for the link here, it's actually 2 and new is 5. And link.rest should be correspond to not 2 instead of not 5. So the rest part of the not 2 is not 3. So I just put in that here. So which means I'm inserting it. Otherwise, just return as normal. And for the insert part, of course, using recursive leap of faith, showing that because I'm proceeding from left to right, you have to make sure that you have to assume that everything on the right side, will be correct by using this function. This function will return the correct part of the right part, and you just return link first. You just return as the start as normal. Yeah. So add the node at the front. So I have a small summary of all this stuff. So if you want to add the node at the front, you set the pointer. You set the pointer of the new node pointing to the old list. So at the node at the back, you look through the old list and find the very end of this list, and then a point and set the pointer of the very last end pointing to the new node. Yeah. So delete. Like try to change the pointer pointing to the deleted node to point to the next one of the deleted node. So try to change the pointer of the node before the deleted node. Yeah. So and avoid hitting the targeted avoid the deleted node. So inserting is like you construct a new list at the part that you want to insert, and then you have the label. The link dot first will still be the old link dot first, and for the rest part you still construct a link, and for this link dot first will be the label of the new one, and the rest part will be the rest part of uh, the rest part of the link that you want to insert at the back of this. On the insert at the back of this. So, and all these situations we are using recursion. So you can still use iteration, but the thing is, if you use iteration, you set link equals link.rest. This which means that you are trying to modify your link by cutting the left part every time, unless you do a duplicate. But for recursion, you can easily construct a new linked list at the return step. So that is why I try recommending using recursion for linked lists when you try to modify them. Because for iteration, you don't modify it. Yeah, you just abandon the linked list once you search and find the result. But for modify, you want to have a linked list. Yeah, you're not trying to modify that on the old list. I guess you must be returning something new. Yeah, you must be returning something new, and this is easier for you to accomplish. So to search, use iteration. I'm not saying recursion is not good, but recommend iteration, because in recursion, I guess you are using something like all or any function if you want to only return true or false, or maybe some labels. Yeah, yeah. So if you want to construct a linked list, as I said, you use recursion. I'm not saying iteration is not good. Yeah, the first thing. Um, but recursion um, can make you construct a new linked list easier. I guess easier because you just for the recursive part, you are only creating. You are only trying to think about. Um, you can only think about a knot, but for iteration, you may not. Yeah. So more about linked list. So what do you think about the link dot first? Like for the label part, will you think it can only be a number? No. It can be actually anything, and also including another linked list. So I have complex linked lists. So link dot first can be anything, like actually including string, including true or false or stuff. But it can also be a pointer pointing to another linked list, like store a pointer pointing to another linked list at the link dot first part. Okay, so I have an example. So suppose I have one, and yeah, suppose I have one, and then for this one, for link dot first, I actually storing a pointer pointing to another linked list 246, and then for next one is 3 5. So complex linked lists, I can consider that as a tree though. I can consider that as a tree. Like for this now, like if you're using a tree, this will not appear though. But you can try thinking about if you have a question like that, you may be thinking treating it as a tree, as a data structure tree. Yeah. So as I said, like linked lists usually have only one branch for last slide, but you can also store a linked list as somehow as some not. So this may be tricky. Treat it as a tree, I guess, my suggestion. So to analyze this tree. So link.res.res. First. As I said, start from the beginning. Link.res will be this part and the remaining part of the list. And then this one actually jumping to the second node by responding to the second node. For the second node, the rest part of the second node, this one is pointing to the node with three. So the first node, the label of the node with three, which is free. So it return free. How about link.res.first? Okay. So start from the beginning and link dot first, this part, pointing to this pointers that stores two pointers. And dot first is a pointer pointing to this node, and link.res is this one, and link.res.first is this one. Yeah. And for the first, like I had to return the label. The label of this now is two, to return two. Okay. Yeah. So try to be careful when you have link.res.first. Yeah. Usually if you only have a very simple linear linked list, I guess it may cause an error or something, syntax error. But if you have, if you actually just encounter a complex linked list, you know, oh, link dot first may be a pointer pointing to another linked list. So link dot first may be the label of the second, the label of the first node of the second linked list. Yeah. So how about link.res.res? Link.res.res. Let's see. Link.res. This part. Yeah. And this part, like this node. The rest part, this node is this pointer. This pointer is pointing to the node with three. So it will be 3 and 5. the list of 3 and 5. Yeah. So how about link.res.first.res? Oh my God. Link.res. This and link.res means this pointer and pointing to the whole thing. And also dot first. Dot first is this pointer pointing to the remaining 2, 4, 6. And we have this, and we have this, and how about this? So we're pointing to the whole thing, and how about this is first, and this will be the rest. The rest is pointing to uh, the list, the list beyond that point. So it's 4 and 6. It's 4 and 6. Okay. So this is complex linked list. So part 5, we are trying to compare Python regular list and Python linked list. So they are both a list of data, but they are different. So this is the table. So type is Python. Oh, I'm using the language Python and regular list and linked list. So there's something different between them. So the first thing is regular list has index. So it is index sensitive. Like you can try find the data using the index. The index is the key of that. But for linked list, sorry, we don't have a key for you, and you will have no idea what the data is stored in the middle of the list. So for regular list, it is index sensitive. But and also for regular list, if you know about the index of a data, you can just modify it directly. Yeah, but for linked list, since you don't know the position, you only have to look through from the first one um, to the one that you want to modify, and then you modify. So you cannot modify. Oh, on the original one. Yeah, for regular list, you can just modify the list itself according to the index. So you can modify on itself. But for linked list, it's kind of hard because you have to use link equals link.res to jump to the next. And meanwhile, you're cutting the left part of the linked list. So you'll be either having a duplicate or trying to construct a new one, trying to construct a new linked list. Not sure. I'm not quite sure if this is absolutely correct, but it is very good for you when you try to program. Try to program. Yeah. It's very good for you to try to program and modify linked lists. You have to create one, not just modify one, modify the original one. And the third one must use a pointer. So linked list must use a pointer unless it only have one node or link.empty. Yeah, pointing to the next one. For the regular list, you don't. If you are not having nested lists, if you are having nested lists, the place where you store the nested list, you are supposed to store the nested list will be the pointer pointing to the list in this list. Yeah. So must use iteration, recursion to access the data in the middle of the list. For regular lists, you don't have to, as long as you know about the index. For linked lists, we don't know the index, so you have to use iteration or recursion. Yeah. So um, applications of this tool in data structure course, computer science 210, yeah, at DVC. So um, how about regular list? Regular list is used like in C++, we use that as an array or a vector to represent a heap. So a heap is also called prioritized queue. So you're using is a kind of binary search tree. And um, actually, they're using kind of data abstraction to use a regular list um, to represent a heap. And how about linked list? Linked list is to deal with data collision in a hash table. So hash table is a dictionary-like data structure. So you are having a list of the data, and you try to have an algorithm to create a key, and then you can use this key to find the data you want. But sometimes, I guess, usually, or maybe very often, frequently, that you use an algorithm, and for different data, it may create one key, one the same key. So if you're using this key, you are not going to have a one-to-one correspondence or one-to-one connection. At this point, I'm using linked list. I'm using linked list to store I'm using a linked list to store, I guess, the stuff of the key, or maybe the stuff, I guess the stuff of the key. And then each time yeah, I don't quite remember though, but you will use linked list to deal with the collisions. Like the data collision is the data in the hash table using a single key, but you are one to multi data. It's not one to one. So using linked list, you are using the linked list to deal with the data collision. I guess it's just either the data in the table or the keys. So um, Python lists and linked lists. So we have advantage and disadvantage of them. So for advantage of Python list is you can access and modify with high efficiency and can be easily accessed. Yeah, because we'll be discussing efficiency later. And efficiency of Python is usually just one because you can just modify the origin on the original one and using the index. But disadvantage of Python lists is your data will be easily changed. Yeah, once you know about index, you can change the data, and it's also sensitive for to position. So you are likely to remember the position if you want to find them. Yeah. But for linked lists, the advantage is that the data is hard to change. If you are not looping through the linked list, you are not going to change that. You are not going to change the data. And for the second one, can flexibly insert and change the position because you don't have to worry about positions. You don't have to worry about orders. All you have to do is using iteration or recursion, just loop it until you find the one. And then you just modify or just return true or false. Yeah. So remember we have an insert node. Like you don't actually have to worry about the place, worry about the index. Like I guess when you are doing sorting on a list, I guess you have to figure out with the index. But for linked list, it's not. Like usually you change the position of linked list is just the deleted or the inserted node and the node in front of it and the node right behind it. So only three nodes, or maybe only two though. So, but the disadvantage of a linked list is that is low efficiency because every time you have to loop, whether you are at the first one or the last one. The first one will be the best case, because you don't have to loop. But for the last one, is the worst case. Usually in a list, if you want to find the last one, just say list index with -1. But for a linked list, you have to loop it through all of them. So it will cost lower efficiency. And you also have to deal with pointers. Yeah. So example of linked list implementation. So this time I use an old example of merge two. Suppose I have sorted two linked lists. So want to merge them. Yeah. So uh try to analyze each step. So for the first two, they are the base cases for if either one of the lists is empty. So you just return the other one and just return the other one. So because they are sorted though. Otherwise, if link one dot first is less or equal to link two dot first, suppose so I have 1, 2, 3, like 1, 2, 3, and 4. Wait, like for here I have 1, 3, 5, 2, 4, 6. So I just need to compare the first two, the first one of these two lists, and then I guess one is the one. So one is the one that's smaller. So I will get one first, and then I will modify that by using link equals link dot rest. Yeah. So next time I just compare 2 and 3. Okay, two is less. So I have to this is a new link. This is a new link. So I I use two, and then I will delete that using link equals link dot rest. We initialize the link. So just to compare 3 and 4 and things, etc. Yeah. If one of them suppose this is 5, this is 4, and if one of them is empty, I just return the remaining the the other list because they are sorted. Yeah. So are the base cases, and for this one, if link one dot first is smaller than link two dot first, I will append link one dot first, and then uh, I will modify link one dot first by cutting the first knot, and link two remain the same. So for this one, I have to believe that it returns the correct path for the right side of the list. For the right side of the list, so everything is sorted and merged well. So, and otherwise, I just return this one, like yeah, merge two returns a linked list, and it's a correct linked list for the rest, and just append link one and to the remaining part of the list. Yeah, remaining part of the list also a list, and yeah, to construct it become a bigger linked list. So else return link two dot first. So this time I just I will construct using the label of link two instead, and then cut the first node of the link two, and then remain let link one remain the same. So it'll be link one, link two dot rest. Okay. So I'm having the practice here. So suppose I have the deleting model. So I have the delete method. I have the remove that we've shown. I have shown before. I'm using for here. I'm using heap sort on the link to try to sort it a linked list. Yeah. So heap sort. Let's do a quick review. Link, heap sort is when you have 5, 1, 3, 2, 4. Every time you find the smallest one among all, and then you construct a new link list by using link dot first will be this one, and this one will be the recursive part, and assume it returns a correct list. So one will be removed, and the remaining I will remove two because it's the smallest, and then append it, remove, and then find the smallest, and freeze the smallest, and yeah, remove three and add it to the new linked list until the link is empty link. It's linked dot is if it's null or if it's linked dot empty, like they're the same thing. Like you just return null because the very last end of the linked list must be a null. Yeah. So can I use that? Suppose okay, I'm having this. So this is base case. I can handle it very well. So suppose is linked empty. So for temp, uh, let's see. I guess that will be a number. I guess that will be a number. Not sure why. What is the temp? Hmm, check it. But I can use this one instead. Um, while temp is to make a duplicate of the link because I'm using a while loop to search in the linked list. Like I'm using while loop to search the smallest one, and I'm using recursion to construct a new linked list. So temp will be making a duplicate of the link so that you can just modify either one of them, and the other one will become the same. So temp will be link. Smallest, I can set link dot first, or you can set 0 as well. Yeah. So while I can use, I have an initialization of temp as well. So uh, I guess you will use link in the while loop, and the temp is that you'll be putting that into the recursion. So they will be removing the smallest one from your linked list, and then you just put it into recursion so that you can have a smaller result then, and just try to uh, combine smaller result and your label, your link dot first to become the correct answer. So I will be modifying link in the while loop. So link, wait, yeah. So link, while link is not link dot empty. If link same stuff, if link dot first is smaller than is smaller than what? Smaller than smallest. Yeah, then smallest will be link dot. Yeah, and otherwise you do reinitialization by jumping from first to second, from second to first. So the link dot. Yeah, you have to do that because otherwise you have an infinite loop. So temp, since I'm having the duplicate of link, so link will be link dot empty after the while loop because I keep modifying link again and again. So temp is the duplicate of link, so it will still be the old link. So for here, I will have to do the remove stuff. So equals temp dot remove. What is remove passing? Remove passing the link and number. So the link is temp. What is the number? Smallest. And return link heap. Link heap is the temp. For here, up till here, it is returning everything correctly from the right part of the link, but I still have to construct the link. So uh, so as I said, like you put the smallest one, put them out, and you put in the first place or the second and then third place in ascending order. So suppose I have taken out one for the first step. So uh I will be putting that at the head of the linked list, which will be the label. Yeah, the label, the linked list. So it will be linked dot first. So for here, I have to construct a link. So for link dot first, I will be having smallest. It's not link dot first, yeah, because it's not temp dot first. Temp dot first is 5 here. So smallest, small, and link dot heap temp. Okay, by running that. This is not remove. Wait, attribute error. Oh, this is a function, it's not an attribute. So yeah, it will be sorted at 1, 2, 3, 4, 5. And remember, here's a trick. Like you can always use a draw function to draw a linked list out, or draw a linked list out in the code.61a.org. So you can draw this stuff. Yeah, you can always draw 5, 1, 3, 2, 4. And I actually have to create like the correct result, output result, but we can also draw that. Uh, so yeah, so like we have sorted this, we have sorted all the stuff. So okay, so I have the solution here. Yeah. So the first thing, all you do is to filter out. Also, base case, you have to filter out if the link is an empty link. It's an empty link. You just return link.empty. You just return where it should be. And then for temp, because for while loop, you keep modifying the link until link will be link.empty. So you are losing your data. So, but I'm only doing searching. So you have to use a variable to duplicate your link. You just say AKA copying the old link so that you can preserve your data. And then you have the smallest to be either one or linked up first. Yeah, either one or linked up first. And for the while loop, you just keep jumping from first to second, looking for smallest. If the smallest from the left side is still greater than the smallest at a sum node, yeah, so you will renew the value of the smallest until you actually find the smallest in the whole list, and then and then you use and then you do the remove. Remove the stuff. You remove the stuff from the link. For here, temp, I make a duplicate of temp because for link it already becomes link.empty while I'm using while loop. So for the temp, I will preserve the values, the data, or the link list. And then all I do is just remove the smallest from the temp. So, and then I do recursion. I using recursive leap of faith by saying that, oh, the link dot heap, I pass in the link, this pass in the remaining part of the link. And I have to firmly assume that, firmly believe in that it returns the correct result. All the stuff sorted. Although I don't have one, like I don't have one here. I have two, three, four, five. I will assume that this return a linked list with sorted, ascending from two to five, a sorted linked list. And all you have to do is to combine. Have to combine. You're creating a linked list by using the label link dot first will be the smallest for here, and the link heap dot 10 it will be the remaining part of the sorted list. So this is recursion and iteration using in linked list. I don't think there's something new here, like only linked list is new. For while loop, you still have to know about or don't have infinite loop for recursion. Um, you don't have infinite recursion for first, and the second one is try to remember recursive leap of faith. Try to remind yourself the recursive leap of faith that can help you solve recursion. Yeah, so that's it for today's lecture. And next week we'll be either talking about SQL, SQL, or efficiency of a program using Python. Yeah, the very end of this course. We only have two courses remaining. So, right, see you then.